All right, students, welcome back. I'm glad you're here. Let's go ahead and look at this problem here. This is a sample problem in stoichiometry, and you're going to have a reaction that I'm going to provide for you here. So it's not written on the document here, but I'm going to go ahead and write it for you. And that reaction that you're going to need to use is the following. Okay, so the following is that you're going to have carbon dioxide. You're going to react that with lithium hydroxide, and the product here is going to be Li2CO3, okay, and you're also going to have water. Okay. Now in the problem you see that the water is referenced as a product, and you also provided that one of the reactants is carbon dioxide and the other reactant is lithium hydroxide. Okay, so the very first thing you'll need to do in this particular case is immediately balance the reaction, because that's the first step that we need to actually get accomplished in order to solve this problem. And so what you'll need to do here is essentially go through that process first. And if you look at this here, I always begin with the very first compound on the far left, and I count the number of atoms that we've got here. And so when you look at this, notice here we've got one carbon atom here, and we've got one carbon atom here in the first product. So at least the carbons are balanced, so we have the right number of carbons. And then oxygen-wise, we have two oxygens here, we have one oxygen here, and then we have three here in the CO3 portion of the anion, and then one oxygen at the very end. So if we go through and do this, if we count the oxygens here, we have four oxygens on the right-hand side, and then on this side we have three oxygens. Okay, and so the only thing that we notice here that we can do is, because we have an even number on the right-hand side and an odd number on the left, the easiest thing for us to do is to look at the two places where the oxygens are and make it duplicate one of them to give us an even number. The simplest one to look at here is LiOH, the lithium hydroxide. There's only one oxygen here, so if we do a multiple here of the LiOH, that'll give us the four oxygens that we require. And so let me go ahead and erase this information that I just wrote here, and we'll do that. Okay. And so here, what I'm going to do is I'm going to go ahead and put LiOH as another copy. I'm going to use this method instead. All right. And if we do that and count the atoms now, notice here we've got one carbon, two oxygens, four oxygens. 3 plus 1 on the right is 4 total, so the oxygens are good to go. And now let's turn our attention to the lithiums. Now, because we added another lithium hydroxide, we've got 2 lithiums, and we see that that is 2 here as well. Okay, and then the last atom that we need to look at here is the hydrogens. We have 2 hydrogens, and there's 2 hydrogens here at the very end. So we now have it balanced, and so all that's left to do here is to actually write down the actual numbers that correspond to these. And so the coefficients are those numbers I'm referring to, and that'll be here 1 for the CO2, 2 for the LiOH, 1 for the Li2CO3, and then 1 for the H2O. Okay. Now that we've got our coefficients, now we're in a position where we can actually solve the problem. And so you want to go ahead and begin here by writing down the information that is provided to you. And so you notice here that you actually start with 10 grams of the carbon dioxide. And so that'll be our first step. And so we're going to have 10 grams of CO2, and we want to convert this all the way to, according to this, we want to know how many moles of the water. So we want to know some number of moles of H2O. Okay. And so in doing this, we need to be able to convert it. Notice the units is a very good idea here to reference the units. Notice the unit here is grams to moles. So I'm going to need some kind of conversion factor that will go here that will provide a relationship between grams and moles. Okay, and so if you haven't figured that out, that's going to be molar mass. And so that's what we're going to figure this out. Okay, so we first need to begin by understanding how many moles of the carbon dioxide I have. Then I'm going to have to go through another step here to figure out what's the ratio between the moles of the CO2 and the moles of the water, which is what I'm interested in. So when I drew the arrow here, I actually was implying that there's actually 2 steps. So the very first step here is going to be converting from grams of CO2 into moles of CO2. And so because of that, I'm going to have to move some of this stuff back. And so let me erase it. instead. And then we'll put this over here at the far end. We're going to have to figure out some number of moles of H2O. But an in between step here is I got to figure out how many moles of CO2 I have. Once I know that, I need to make another jump to figure out how many moles of CO2, and that'll be the second jump that I was referring to here. In which case, we're going to be looking at the moles of CO2 as a ratio of the moles of H2O. Okay, and so that's how we're going to set this up, and let's go ahead and do the math now. So let's go ahead and begin first by making this a little bit smaller if I can. Let's see here, I can make this a little bit smaller there, and let's minimize this a little bit. Okay, and that'll allow me some space to write. All right, so the very first thing, we're going to start with 10 grams of CO2, and in order for us to convert it into moles of CO2, I need to use the molar mass conversion factor. And so that means for every 1 mole of CO2, I need to divide it by a certain mass of CO2. Now, I'm going to do the work over here on the top right corner. Okay, so CO2, and so that means that you've got 1 carbon atom and 2 oxygen atoms. And so the carbon, I'm going to use just whole numbers here, is approximately 12. Oxygen is approximately 16, and the other oxygen, obviously the 16. So when you add these numbers together, that'll be 10, 20, 30, 42, approximately 44 grams per mole. Okay. Now go ahead and add this up precisely on your end. Go ahead and report to the right number of sig figs. In this case here, I have 10, let's just go ahead and put 0.0. So we have 3 sig figs total. So I've already made the adjustment there. And if we do that, we'll come up with the following mass. Okay, so the mass that I get here is 44.008. I'm going to go and put this many sig figs only because it's at the very end that we're going to round. Okay, and so now that we do that, if I were to go here, notice what's going to happen. The grams of CO2 is going to cancel. Let me change colors. And so grams of CO2 cancels, grams of CO2. So up to this point, I have moles of CO2. Now I got to figure out the ratio between the moles of carbon dioxide and the moles of water. And so in order for me to do that, what I need to pay attention to here is the coefficient. And so notice here the coefficient here is 1 to 1. So how do I put that? Well, I'm going to need a mole ratio, and that means for every 1 mole of carbon dioxide, I produce 1 mole of H2O. Okay, and then again here, the moles of carbon dioxide cancels, top and bottom, and you're going to be left with the moles of water, which is what you're trying to find. Okay, and so go ahead and solve this out. You want to go ahead and begin by taking the 10, multiply by 1, multiply by 1, and so on the top, you should have the following number. I'm going to take this in steps here. And then I should have moles of H2O at the very top. And in the denominator, I'm going to have 44.08 times 1, which essentially is 44.008. Notice there's no units. And so if I kind of go through this and actually do the math here, you should be able to get the answer that you needed here at the very end. And that value is 0.227. I needed 3 sig figs. Notice here the number behind it is a 2 if you actually do this. But because this number is smaller than what we need, we are not going to use it. So the number is 0.227, and the units here is going to be moles of H2O. And this is our final answer. All right. So if you haven't already done so, go ahead and keep watching, keep learning. Also subscribed, and we'll see you in the next video.